Hello. Today we're going to build up a Trans-Ionospheric badge as received from the contract manufacturer. Here it is in this bag, and we'll take it out. So the manufacturer has populated the reverse side for us mostly. We've got the processor, the BMD300, the SD card socket, voltage regulator. We've got patterns for both a boost regulator and a buck regulator. The boost regulator is populated, so we'll be installing a 2-cell battery pack. Here's the main switch. The NFC antenna is here. These are support components for the switches, and this is the connector for the LCD. Battery packs go here. You can see we've got a layout for 2-cell and a layout for 3-cell. We'll be using the 2-cell layout here. On the front, nothing is populated. So there are places for LEDs, 5 across the top, 1, 2, 3, 4, 5, 6 around the dial, and 4 across the bottom. The display is going to go here, and 4 switches here and 1 switch there. First, let's check power to ground, because we have had one power to ground short. The easiest place to check it is here on this add-on connector. It's got VCC and ground all nicely labeled. So if I check across there, no beep. So good, no voltage power to ground short. We should nonetheless inspect the LCD connector, because that's by far the finest pitch component that we have any chance of inspecting. There's lots of pads under this BMD300, but there's no way to see them. So we need to look carefully at all these little teeny solder joints right there. In order to look carefully, the tool of the day is a stereoscope. Okay. Everything appears to be good with the LCD connector. I've also inspected the SD card slot, because we did have some bad solder joints, or a bad solder joint on that. So we're good to go with some soldering. In order to test these things as we build them up, we'll install the battery holder first in order to get power to the system. Now, before we solder on the battery holder, which goes like so, there's a jumper I want to install. Now, this is a workaround for a problem in the circuit board. It turns out that this area here of copper plane, which is supposed to be part of the ground plane, is not actually connected to ground anywhere. So the easiest way to solve that problem is to put a jumper across from the ground pin for the 3-cell battery holder to the ground pin for the 2-cell battery holder, so that this happens to be inside the isolated plane. So that connects the two. And the way I've worked out to do that is to connect the wire to the pin of the battery holder before I install the battery holder. Put the other wire in to the circuit board. So let's do that. Okay, now test fit it into the cut to length. Strip the end. Bend it down. Now we're ready to put this on, but what holds the battery holder on is some double stick tape. Place it on the battery holder. and give it a good press for some period of time. I think the specs call for 30 seconds. Now this goes. That wire's in place. Push the battery holder down in alignment and hold it down for a little while. Okay, good. And solder. Push the battery holder wire, or the jumper wire, rather. There we go. And then the battery holder leads. This one's a little hard because it's connected to the ground plane. It's harder to get it hot. Here we go. And trim. Okay, now we're in position to power up the board, but we won't really be able to tell very much whether it powered up or not, because so we don't have any LEDs yet and no display. So the simplest thing to do is just go ahead and install the display. Let's do that. Here's the display. It's got a little flex circuit that connects on the back side. Comes provided with two tiny little strips of double stick tape. So we peel the tape. One, two. Make sure the flex is routed through the hole. Put the alignment pins into their corresponding holes in the circuit board at the top of the display. It forces it to be in the right place. And then push it down. Give this double stick tape a chance to stick. The LCD connector just hinges up like so. And we fold over the flex. Make sure it lies inside the connector where it belongs, properly centered, and just hinge that guy down. That's all there is to installing the display. There's a couple of batteries. They go in the usual way. And you can see the display is lit up rather dimly. That's because I forgot a step. My mistake is here. We've got R14 and R15, which you may be able to see. Those are 0 ohm resistors, and one of them needs to be in place in order for the backlight to be on. R14 bypasses the switching transistor that lets the processor control the backlight, and R15 enables it. We want R14 right now because we don't have any firmware for backlight enable. In order to do that, I need a 0 ohm resistor. I just happen to have a strip of them here. Okay, this solder that's already on the board is fairly high temperature, probably lead-free solder. It's kind of annoying to get it to reflow. I think that might have worked, but I need my magnification. Okay, with R14 installed, albeit not as pretty a solder job as you might like, turn this guy on. Display is at full brightness. Now nothing's on the display because we don't have firmware, so let's fix that. The J-Link with an adapter gets us to this tiny little connector here. That tiny little connector goes in here. Power on the board. And run the download routine. There it is, running the firmware. There's a micro SD card that's been pre-programmed with the appropriate stuff. Like so. It takes a substantial amount of force to make it going all the way. There we go, now it's in. Now if I turn the board on, it should behave slightly different. It'll bring up the welcome screen instead of the factory test screen. There it is. Notice we're still running firmware from the Joko badge. We haven't customized the firmware for Trans-Ionospheric yet. It now wants me to push a button. Well, I haven't installed the buttons yet, but I can take a pair of tweezers and pretend to push a button. So here's the button. Okay, it pushed. That's good. I can accept monkey as a temporary name, then it'll go through the boot sequence. Good. Okay, so that button works. Let's go ahead and install the rest of the buttons so we can test the menus and stuff. I've got the camera set up to give you a little bit of a view of the switch pads. Well, I can actually see them through the stereoscope. And just blob a little bit of solder paste onto each one of these pads. The trick is metering the solder paste out. So if you give it a good squeeze, it comes out like crazy and then keeps on coming out because it's pressurized in the flexible plastic container. So instead of doing that, we'll just let it ooze out really slow under modest pressure. This gives us a chance to control, to some extent, where the solder paste goes. Doesn't take much on each pad. It's hard to control exactly how much goes on the pad with this method. Luckily, it's not critical. Okay. Good. So that's solder paste on those 5 switches. And we'll just plop the switches down onto the pads. One. Two. Three. Four. Five. Okay, now the trick is to heat these up with a soldering iron while holding them in place. I only really need to get one leg of each, but getting both on the same side is just as easy. So that one's soldered down on 2 legs. Okay, and I'll do one side of the action switch as well. Okay, now I'll just turn the board around so that I have access to the other side with the soldering iron, and I don't need to worry about holding it down anymore because they're soldered down. This is approximately 1 billion times easier than doing it with wire solder. Okay, with a little luck, we can demonstrate that this worked. Let me hold it at the right angle for the camera. Turn the system on. So you can't quite focus there. Let's do it like so. Alright, action switch works. Alright, down switch works. Now I can go to the test screen. There it is. Down, see the green, right, yep, up, action, and left will actually bounce you out of the test screen. Okay, 5 switches installed successfully. There's one other switch that has to be installed, and that's the tilt switch. It's mounted right here. So there's the tilt switch. The secret code here is that one side of the tilt switch is gold, the other side is tin. So the gold side goes toward the top of the board. And we also mount it at a funny angle so that when a board is perfectly horizontal, that looks like straight up, vertical. These holes are just barely big enough for these leads. Okay, gold on top, and then kicked out at a jaunty angle. There it is, like so. And trim. Yep, see, it flips. Tilt switch works. Alright, we're going to mount the LEDs on this board. This is done the same way as the switches, by putting some paste on the pads, then plopping down the devices, and soldering, heating it up with a soldering iron. I do the LEDs in batches, the first of 5 across the top, because they're the first in the serial data chain from the processor. Then I test them, then I go around the rest of the chain, 3 on one side and test, 3 on the next side and test, or no, the 4 across the bottom next, and then the 3 on the other side, and then the 1 on the back. By testing at each juncture, I theoretically reduce the amount of rework that would be necessary if I managed to screw one up, short power to ground, or something like that. Plus it gives me a nice satisfying LED blink for a break between soldering. See that solder paste is a little better behaved now that I've got past the dried stuff at the end of the tube. Okay, so I got paste on those 5 across the top. Get 5 LEDs out of their little strip. I'll just dump them right onto the board where they'll be handy, hopefully without sending them flying across the room. The switches can go either which way, but there's only one correct way for the LEDs. It's this way. Okay, all 5 are placed. Visual cross-check to make sure they're all oriented the same way and that it's the correct way. Yes. So now it's just a matter of heating up the pins and reflowing that solder. It's not enough to melt the solder paste. You also have to make sure it wets the leg of the device, or else you get a nice puddle of shiny solder that's not connected to your part. It kind of defeats the purpose. Okay, that takes care of all 5 of those. Turn around. Solder the other sides. On the test, turn on the board, get past the startup screen, go into bling mode, and sure enough, all 5 of the LEDs are blinking. Awesome. On to the next LEDs. Solder paste. Now, having the battery holder already installed makes this harder because the board won't sit flat. But I think you can see that it makes it really easy to test and verify that things are going well. And as a trade-off, I prefer that. I built up one board without installing the battery connector. And when it didn't work, I didn't know what to fix. Okay, solder paste on 3. Orient correctly. That way. In place. 1. 2. 3. And solder. Trying to keep my hand out of the camera makes it more awkward. need to be more awkward. You might be able to see that these 4 LEDs have an additional component next to them, which is not currently populated. That's a bypass capacitor. For the other LEDs, the bypass capacitor is on the back of the board. These LEDs are in front of the battery pack. And so the bypass capacitor has to go on the front. We'll put that on after we put on the LEDs. And test. They blink. Okay, notice only 2 of them are blinking. That's actually normal behavior because the software we're running right now only drives 14 LEDs and this board has 16. So we'll have to test this final LED on the front and the one on the back later with a different software rev. So now on the back, we got an LED that goes here. Now, because this back side was soldered by the manufacturer, we've got high temperature solder on those pads, and it's a real pain in the neck to solder those, to reflow that on an LED, which is temperature sensitive. So what I prefer to do is remove the high temperature solder using solder wick and then put on my own paste. Get a fresh end on the solder wick. Sometimes this is a little messy. The soldering iron is able to melt this solder, but it seems reluctant to melt sometimes. Come on, you solder. there's most of it off. So even just putting the soldered iron directly on it barely melts it. Maybe I'll turn up the temperature a bit. Yeah, that's how it's supposed to work. Okay. And get away with not trimming it. So they're not completely dry, but most of the nasty solder is off them. I can put my own solder on from the paste syringe. And plop one final LED down. Not really supposed to land right on the solder paste, but at least it landed face down. Again, orientation. All the LEDs that are supposed to blink are blinking. And we got to go back and install those bypass capacitors. These are very small. The LEDs are positively huge by comparison. But on the bright side, there's only 2 terminals. And it's not that hard to get them stuck down. So just a little bit of paste on each pad. I found my capacitors. These are really easy to lose. Let's see if I can keep track of all 4 of them. So far, so good. One. Two. 3. 4. 1. 2. 4. 1, 2, 3, 4. Okay. Now test again, make sure I didn't short anything out. good. The LEDs are lit up.